Good afternoon, ladies and gentlemen. Welcome to today's webinar. My name is Christopher Brent. I am the Senior Membership and Meetings Coordinator with Utilities Technology Council, and I'd like to thank you all for joining us. Today's webinar is sponsored by Future Technologies and is titled, Where Does Connectivity, Compute, IoT, and Use Cases Come Alive? Just to give a few housekeeping notes before I hand it over to our presenters today. This webinar is being recorded and will be available for on-demand replay for all of our registrants. To be able to access that recording, we will post it in UTC networks in a community dedicated to this exact webinar. We will be sending out an email to all registrants once the replay is available, as well as certificates for your continuing education credits. And for questions, please feel free to submit those questions in our GoToWebinar control panel in the questions section. We will hold all questions till the end of the presentation, but please feel free to submit them as you think of them. And without further ado, I'll hand it off to our presenters at Future Technologies. Thank you all for joining us and enjoy the presentation.
Hey, thanks, Christopher. We appreciate UTC making this available for us today. We've got a great panel, folks from all over the industry, and looking forward to presenting to the group. We also want to thank the contributors and the attendees for coming and spending time with us today. We know time is important, and we appreciate you spending time with us. So thanks for joining. Just want to make sure we can see the presentation. Everyone can see that? Yeah? All right. So from a panel perspective, Pete Cappiello, CEO of Future Tech, moderating today. We have Gary Hill, our Vice President of Solution Architecture from Future Technology, who's going to do a tour for us. We have Bhapesh Agrawal from Intel joining us today to contribute on the ecosystem side. We have Bruce Collins from Cambium Networks, Senior Director of Product Management, helping to overview Cambium's view of the utility world. We have a great use case to talk about today on drone and drone management and drone programs from Skyward with Mike Denelek from Skyward. And we also have Dr. Mauricio Sabuda from Nokia on today to talk about Nokia in the utility market. So we appreciate everybody joining us today from the panel. Lots of different perspective. Hopefully we'll bring some value to the discussion. A little bit on Future Tech. We're a lead system integrator based out of Atlanta, Georgia, founded there 22 years ago. We currently service about 100 utility customers, so we definitely appreciate the market and being part of the ecosystem. The purpose of today's webinar is to talk about our innovation center and bringing together ecosystem partners to help our utility clients innovate. So, our company, we have a 6-step approach to our client engagements. We view step 2, our innovation center, as a pretty unique step in the process, which Gary's going to walk us through today to kind of bring together ideas and make them a reality. We've blended together connectivity, compute, and also use cases into the environment. So remote expert, computer vision, drones, asset health, IoT sensors, edge computing, mixed connectivity, narrowband, Wi-Fi, private cellular, public cellular, to make it really indicative of a client environment. And then we've also added in some advanced edge analytics and edge compute platforms in addition to that. So, with that preface in mind, I'd like to hand it over to Gary Hill. We're going to do something a little different where we're going to actually do a live tour through the facility. And in order for you to get the best view, we're going to stop sharing the screen. And if you could click on Gary Hill's tile and expand it out, it'll give you the best view of the tour. And we'll hand it off to Gary.
Hey, thanks, Pete. So again, Gary Hill. I'll do a quick mic check and make sure we got good connectivity here.
Yes, sir.
Okay, let's go. So hey, appreciate your time today. We're going to do a quick tour of our innovation center here in Suwanee, Georgia. So we're going to start kind of at the front of the house. Part of our innovation center is dedicated to meeting space, a computer room, as well as a network monitoring center. So we'll do a quick tour of that, and then we'll hit the industrial space in the back. So let's go into the computer room. This is where we're doing our edge computing, running our private networking capabilities, as well as also other software for things like computer vision models. So here's, for example, a Intel NUC device. We're running our computer vision software models on that particular device, as well as powering our private network with the rest of the compute here. Again, we also continue to expand our compute capacity with Intel here as we grow our use cases. Again, our belief, especially working with industrial clients, having edge capabilities is going to be very important to demonstrating use cases here in our innovation center. We also recognize the power of the cloud, though, so we do work with all the hyperscalers, AWS, Microsoft. Here's an example of a Azure stack that we have here in our innovation center. This is a project where the client uses Microsoft Azure, so we're running kind of the edge compute stack on that platform as well. So again, we can integrate with the hyperscalers. We have pretty good connectivity out of our facility here, a gigabit pipe back into the cloud for our SaaS services. Let's kind of hit our network operations center very quickly. So this is where we monitor the internal networks here in our innovation center. So again, a couple panes of glass into our Cambium network as well as our Nokia private network. So this is really focused on the innovation center. However, we can also monitor from this facility for our clients, either running POCs or production as well. Let's hit to the innovation center now on the industrial side of things. Thank you, Roger. This is about a 10,000 square foot facility. We've really have a mixture of industrial manufacturing. So on the left-hand side, we manufacture cell on wheels. So these are 4G and 5G systems we're building for the military that will eventually go out. These will go to bases. They'll be set up and basically run a network there. On the right-hand side, we're trying to emulate some space for warehouse management, logistics, so we can do some AGV robotics type use cases. So again, kind of more of an industrial feel here. So again, as Pete mentioned, what we're trying to do here is really take networks, edge computing, and use cases and really bring that alive. So when we bring customers here, they can experience, put their hands on the solutions, and actually see how things work. From a connectivity, we have built 2 towers inside the warehouse. So this is one of our towers where we put connectivity on the right-hand side. You can see our Nokia Pico cell for our NDAC private network. Left-hand side is a Cambium AP for Wi-Fi 6. At the top, there's also a Cambium C and Wave. That's basically a 60 gigahertz wireless backhaul that we're running here in the facility. As you come down on the bottom, we're also giving you an example of an outdoor private network antenna. So this is a little bit larger, obviously higher power, and a little bit more robust for having outdoors. So again, we're trying to show real world use cases of connectivity. Again, there's a tower in the back with very similar technology mounted on that. So we're going to take a walk down into our innovation center. To the left-hand side, as we approach, we have an area we do demonstrations to customers for various use cases. We'll take a look at that in a moment. First thing we're going to hit is some examples of some private, portable private networks we built for customers. So a lot of customers maybe aren't ready to make the investment to go production with a private network. So we've basically been able to put these portable networks together. Again, this is a 2-case system we can ship to. The core runs in the right-hand box. The radio network is in the left-hand box. We can ship you a variety of antennas that go into that. So again, a lot of flexibility there on how we can put those together. Here's one more example of a very similar unit. Again, this is all in one tactical case, has the core and the RAM built in together. So again, a lot of flexibility for our customers on building a private portable network. We'll quickly take a look at the inside of the cell on wheels. Again, very similar. We have our core running inside the box as well as a RAN network. This happens to be a T-core network solution. Again, ruggedized, ready to go. Maybe get a shot there of the 5G antennas. All right, let's take a quick look now at our demo environment. So here's where we have a set of use cases that's using all this connectivity. Our first thing we like to demo is IoT solutions. It's called IoT in a box. It's a way to really put sensors in your environment for over 400 types of sensing. This particular solution uses LoRaWAN, so the devices talk LoRaWAN back to the gateway. Again, very long distance, low power. The batteries in these sensors last a long time. Here's an asset tracking solution of asset tags you can place on your equipment, or even people can wear these to know where people, assets are in your facility. There's a panic button solution. We do temperature sensing, leak detection. Again, these are just 5 or 6 of 400 type of sensors we have. We also have a use case for computer vision. We'll see that in a moment. We have cameras in the facility on the towers and the ceiling. where we basically can take video of the environment in real time, run computer vision models for things like PPE detection, intrusion detection. We'll take a look at those in a moment. And we also have a remote expert connectivity solution, AR, VR headset with LibreStream software for remote expert. Our last demo solution is around asset health. This is pretty important for industrial customers that are trying to be more proactive on maintenance. So this is a solution that can basically put vibration temp sensors on your assets. Here's an example of a small industrial motor. These sensors go on it. They're magnetic, transmitting signals over to the gateway box, and this backhauls into the cloud service. We'll pop this open very quick. This particular gateway box has a public cellular card inside of it here, Microtech. This could be replaced with a private cellular interface if we want to go that direction. So again, a place we can experiment with our customers, we can experiment with our technology partners to look at the different options in the market. So I'll just hit a couple slides very quick. As we do demos, we also like to walk our customers through the use case, the problem. So here's an example of asset health. Again, this is a big solution set for industrial clients trying to monitor their assets so they can predictively know before they go down, so they can perform maintenance. Again, it's a very, very big return on investment, typically millions of dollars a year in savings by proactively doing asset maintenance. Computer vision, we mentioned, basically is using cameras to emulate human eyesight, running those images into a computer vision model to do object recognition and things of that nature. And then remote expert, again, wearing AR headsets. It could be a tablet, an iPhone. Really, you have deployed people in the field. You have centralized experts. So these centralized experts via the technology can assist those employees without traveling. So it can cut down on your cost. You can really share your experts more efficiently across the organization. When COVID hit, many people couldn't send their experts into the field. So this is a very critical set of solutions to keep production running. Also supports digital workflows. Many companies are still very paper-based, so this platform lets you digitize those workflows as well as the remote expert capability kind of integrated together. Then we mentioned IoT sensors. So again, using relatively low-cost sensors to sense a variety of things in your environment, send that up to our cloud service through our LoRa gateway, and then you get alerting and texting back to your mobile devices, your email account. Just an example, again, over 400 solutions across multiple industry verticals. So if you can sense it, we can add it into our platform. So again, just an example of that. Today, again, connectivity is just a quick example. So we have a computer vision camera mounted here on top of the TV for a use case. In this particular example, we're backhauling that video stream to the computer vision model over a private cellular modem. So again, trying to demonstrate use cases over a variety of technology connectivity. Pete, I'll turn it back over to you. Appreciate your time.
That's great, Gary. Thanks very much. And
thanks.
Our goal with the facility is to, again, create a petri dish that we can experiment with and demonstrate things, virtually this way. But based upon time constraints, we didn't do any demos. But we're going to provide Chris's contact info from Future Tech in the slides, and we'd be happy to set up 1-hour demonstration sessions with the clients that are interested. And this is more just to give a look and feel of the facility itself and how we're bringing in connectivity, computed applications, and showing it kind of live for the group. With that being done, we're going to shift back to presentation mode. Are we able to see the slides? Yes. All right. So up first is Bhupesh from Intel. Bhupesh, welcome.
Thanks, Pete. Hello, everyone. Good morning and good afternoon. So I'm going to talk about the requirement of a solid ecosystem for private networks. As we all know, the private network is very different than the public network, but then there are many players. So we'll go through some of those things, and we'll see why this partnership, our partnership with Future Tech, where Nokia, Chemium, and others are part of this, is really important. So next slide, please. So we are going to talk about the 3 layers of private network. As you are looking at the private network, there are 3 layers, and you will see why why a solid ecosystem is required. So the first layer of a private network is the network infrastructure. This is the part that Gary was talking about. It contains the radio network, radio access side, the edge computing, the packet core, and the cloud side. The second layer is about the virtual network function. This contains like SD-WAN, firewall, and the third one, which is equally important, is the IoT use cases and the application. Gary talked about several use cases. The reason why the applications are really important in the context of private network is because the problem starts with a use case. And when you look at an enterprise has a use case or a problem that they are trying to solve. Private network, like the cellular technology, it's just a means to solve that problem. And like if we go to the next slide, when you look at the traditional model on your left hand side, you see like in the traditional model or even the public network kind of thing, you have only limited players. You have these telecom equipment manufacturers and you have these service providers. But as we look at the private network, you have the equipment manufacturers like my colleague here from Nokia. We have the comm service providers, the carriers that we know of. They play a big role. We have a new partners from like on the radio side, on the edge side, even the packet core side. So there are new vendors that are coming up for the private network. We have the new managed service providers who already have relationship with the enterprises, and then cloud service providers are also playing a big role in the private network. And we'll talk about those ones, how these building blocks, different building blocks of private network are related to these partners and how the partnerships are happening between them. Right? So next slide, please. So this is a good example, right? It shows how the carriers are taking it and how their partnerships are happening with the cloud service providers. So as you can see from this, if we go through again the layered approach, right? We all know that the carriers have a pretty good handle on radio access side, right? They also have a good handle on the packet core and the virtual network function side. What the carriers are missing right now is the multi-access edge compute infrastructure, the cloud infrastructure, and even the applications. Because remember, in 3G, 4G era, like these carriers focus more on the consumer side and not on the enterprise. On the enterprise side, their model was more focused on the wholesale side. So this is where like you see these more and more partnership with these carriers like the AT&Ts, Verizons, with big cloud service providers, because the cloud service providers are providing them the edge infrastructure and the applications. If you go to the next slide, please. And this is a good example on why private networks, when it's coming to private networks, why there is a reverse partnership, right? So you see these cloud service providers, we all know that they have a pretty good control over the public cloud. They manage the largest data centers. There are partnerships happening for the packet cores. Microsoft recently last year acquired Affirm Network and MetaSwitch. Amazon has partnership with Ethernet, and then there are other partnerships that are also happening. They bring multi-access edge compute infrastructure. Gary talked about Microsoft Azure Stack. The one piece that they are missing right now is the radio access side. And this is where they are focusing on right now. But again, the bigger point is that this is where the cloud service providers are also working with these carriers or the comm service providers to bring the full complete solution for the enterprises. Next slide, please. So what does these enterprise need, right? There are 4 requirements that they have. One, starting with the use case and problem. I talk about the requirement, the need for a use case. Like enterprises are starting, unlike public network where the infrastructure is put in place first and then the applications come later, private networks start differently. Private network starts with a use case, the problem that these enterprises want to solve, the applications side. The second one is they are looking for reliability of a LAN and the flexibility and mobility of a Wi-Fi. And this is where the private network is very promising because it can deliver those both. And on top of that, it can also deliver the security and the control of data that these enterprises are looking for. The third one is these enterprises, because they are going through a learning curve right now. Remember that they have the expertise in the LAN side, they have the expertise on the Wi-Fi side, but these enterprise IT department and the other operations team, they have never touched the cellular technology. So they are not well versed in the cellular technology, and that's why they want to deal with they don't want to deal with multiple stakeholders. They want a single point of solution where somebody can come, deploy it, and manage it for them. And then the fourth one that I talk about already, it's they are open for the managed services because they are still going through the learning curve. Whether that they will gain the expertise by hiring the individuals or by through the experience over the period of time, we will see. But for now, as we are talking to enterprises, we are seeing that they are very open, like, hey, as long as you solve my problem, as long as it the private network delivers the KPIs that I am looking for, as long as I do not have to deal with multiple stakeholders, I'm fine with somebody coming and managing the services for me. So next slide. And this is my last slide. This is where our partnership with Future Tech is really becoming exciting because we have partners like Nokia, CWave, Skyward, and the Future Tech's experience that Peter talked about, the 22 years of experience. Because if you have any challenges in terms of the use cases and all, and you're looking for a single point of solution, this is where all of us are coming together, working with Future Tech to provide you an end-to-end solution. Not only that, we will make sure that it's optimized. So whatever the compute that you're using for edge or for even cloud, those applications are optimized running on Intel architecture. So that's why, like, I feel that the need for a solid ecosystem as the landscape of private network is changing is really critical. Otherwise, if we are just gonna individually touch these parts, then the enterprises will feel the challenge of tackling with like problem of many, right? Because you have these many stakeholders in the overall landscape. So that's it from my side. Thanks, Pete.
All right, great. Appreciate it, Bhupesh. That's really good information and provides a good perspective on the ecosystem and the importance of everybody working together as we go forward with these next generation use cases. So up next, we've got Bruce Collins from Cambium Networks, who's going to walk through Cambium's view of the utility market, some traditional items and some new items. So I'll turn it over to Bruce.
All right, thanks, Pete. Thanks, Gary, for the great tour. As you mentioned, I'd like to cover a few of the use cases that we see, particularly in the electric and water utility space. And what's really kind of driving all of these is the increase in capacity and the increase in the need for data in a private network. And we see this as complementary to some of the public networks that are out there, but it's a way to really extend the network wirelessly deeper into the field area network. So we certainly see a new migration towards gigabit per second capacity. You'll see a lot of different techniques and how do we move from what was traditionally SCADA communications at kilobits per second, and we moved to megabits per second for video and fieldcraft access, and all of a sudden we're talking about gigabit per second, and the technologies are keeping up with that, and there's a lot of really exciting things happening in that space. So I'll mention a few of those things, but really one of the things that Gary mentioned was remote expert. When we talk about video surveillance, it's not just static monitoring of security of assets and people. It's now more interactive and doing remote troubleshooting and remote analytics that drives additional demand for capacity. Now, every field craft that's out there working in the field needs high-speed connectivity. So if you can put that on a secure private network, that's another great example of how utilities are deploying these networks. And then, of course, the traditional meter aggregation and backhaul, that continues to expand in the need for capacity. So we really see those are the use cases. What's common about them is the driving the need towards this gigabit per second to the field area network. And some of those exciting spectrum advances and technology advances you can see here on the right hand of this slide. We've been in the multi-user MIMO space for several years now with our PNP450 platform, and that really started to break that gigabit per second barrier for a private network in 5 gigahertz. Also, the introduction of CBRS band in the US has been really successful. It's kind of a trial balloon, if you will, for the FCC to test sort of lightly licensed spectrum that has layered access, and so you have some layers of exclusive access and general access, and control is advised by a centralized set of frequency coordination tools. That's been a really successful rollout over the last 18 to 24 months, and I look for that to continue, and that's in 3.5 gigahertz today. The next thing that's coming in that space, and it's similar, is Wi-Fi 6 or Y6 based on 802.11ax, and then the Y6E, which extends up into 6 gigahertz. That's also a new trend. That 6 gigahertz deployment in the FCC environment, at least, will also use that frequency coordination, and it's going to deliver multiple gigabits per second, whether you're doing traditional Wi-Fi access or if you're using Wi-Fi chipsets and technology to deliver fixed point to multi-point, point-to-point solutions. We're very excited about millimeter wave and the advances in 60 gigahertz. I'll spend a little bit on that on the next slide, but before we move there, the other thing that I think Gary mentioned was private LTE as a complement to the public network and the carrier networks. And then licensed microwave continues to be sort of, literally the backbone of utility connectivity. And the advances there are we're moving into 80 gigahertz, multiple gigabits per second, 20 gigabits per second as an example. And you can mate that and marry that with some of the other frequencies like 11, 15, 23 gigahertz. And you can use that combination, what we call multi-band, to build up high capacity with high availability. And that's really what you're looking for in a secure environment. So lots of things happening. Really need to keep your eyes open as you look at all of these things evolving over time, but just know that gigabits per second is here today, and the options continue to expand. You can go to the next slide. Real quickly, the CWave product is based on our 60 gigahertz. This is what we call Teragraph certified. It was a technology that was incubated by Facebook Connectivity, but we're very excited about this as a alternative to fiber. You can see it's cost 41% of the cost of fiber and much quicker to deploy than fiber. There's no trenching. You can kind of see the complexity on the right there of a fiber plan versus a millimeter wave wireless plan there on the left. So again, 41% of the cost of fiber, but with fiber speeds of multiple gigabits per second. So very exciting. This is a product we launched in late last year, and we're starting to see more and more, whether it's electric utilities, water utilities, freight rail, class 1 freight rail operators, a variety of different utilities and industrial applications using 60 gigahertz. You can go ahead, Pete, to the next one. Another area I just mentioned briefly is we see the expansion of electric co-ops operating as service providers. So leveraging the fiber that they have deployed, leveraging the wireless backhaul that they have deployed, and then providing internet service as a complementary to their electrical service that they're offering. We have one great customer here that we work very closely with, GVEC, but there are many others throughout the US that are operating in this mode. And again, they're using licensed microwave to deliver a gigabit per second plus everywhere, and then feed out 100 megabit per second, 200 megabit per second service plans to individual residences. And it's a way to open up the business model for an electric co-op. And then I think I just have one last slide, Pete. Where that all comes together is we see a series of requirements as you go and talk about what am I trying to accomplish in the utility space is really a combination of how far do I want to go, what's the distance, what's the capacity, and what's the availability. So what's the reliability of that link? And you look at all of those trade-offs and you say, what's the best technology for that? And that's where our partnership with Future Tech really comes into play, is that with the Innovation Center, we can put together multiple combinations of these pieces of technology along with the other partners on the call today. And you can actually see and demonstrate end-to-end connectivity where you're delivering, whether you're looking for a multiple gigabits per second over a few kilometers or a kilometer, where you're looking for 5 gigabit per second or more over a kilometer, or if you're looking to go 7-10 miles with hundreds of megabits per second, you can do that as well. All of that managed from a central place with our CN Maestro platform, which can drop in to your operations systems with the Northbound API. So lots of different flexibility here and lots of ways to connect up all of these different areas. So with that, Pete, I appreciate the opportunity, and I'll pass it back over to you.
That's great, Bruce. And what you described is exactly accurate. I mean, what Gary demonstrated, we're using the Cambium LAN to actually backhaul the Nokia private LTE radios. It's also connecting up to the Intel NUC for edge computing. And because that's, you know, many customers have existing infrastructure. They want to bring something new in. Being able to work across different technology vendors and have everything work as expected, especially for these advanced use cases, is really important. But you know, great overview, Bruce. It's interesting to see you guys all the way down in what 200, 400 megahertz, all the way up to 60 gigahertz now, and from a frequency perspective, that's pretty impressive. Yeah. So next up on the presentation is Mike from Skyward. He's going to walk through a pretty cool use case. I'll turn it over to Mike.
Thanks, Pete. Hello, everybody. Yes, the Sky is open for business. It's been open for business for about 5 years now. That's when the FAA passed new Part 107 rules that would allow commercial drone operations. Prior to that, you had to be a pilot, a crewed aircraft pilot of some sort, to actually fly a drone commercially. Next slide. So what I'd like to do is give you an overview of what Skyward is, who we are, what we do, and focus on some utility use cases. So very broadly, the basis is our drone management platform. It's a SaaS-based software platform, and I'll talk about that in the next slide in a minute. But we also do more than that. We also provide consulting and training so that we help somebody stand up a program from scratch. So even if they have no aviation expertise, but they want to use drones, they want to leverage drones, we can help them create policies and procedures, corporate policies and procedures, and training, and real hands-on training. Right now, you could actually pass the FAA drone exam without ever having touched a drone. And when we help people start up a program, when we leave, they are not only safe and know what the rules are, but they're also productive in the field and know what they're doing and can get the data they need to get. We also sell aircraft and hardware. You know, aircraft, you know, it's not a high margin business, right? But we mostly do this to benefit our customers, because the people running drone operations, typically that's not their day job until they get very big programs and they're managed by the aviation department at a customer. And so what we do is we consolidate the hardware and accessories and make it easy for them to, instead of spending all their time trying to procure all this and figure out what accessories go with what drones and what they need in terms of an aircraft to implement the type of job they're doing, we do that for them. What we're really excited about now is our new LTE connected drone that we're bringing out with Parrot. They're a French manufacturer of drones. We're working with other drone OEMs too, but they're going to be one of the first to have a commercial off-the-shelf drone on the Verizon network that will enable them to not only fly how all the other drones are being flown today, which is unlicensed spectrum, basically Wi-Fi. This will give them a much more secure and reliable connection and enable them to fly much longer distances, which will get more use out of the drone. And then lastly, as far as that connectivity goes, as I said, we're working with different OEMs. So we also work with customers on applying connectivity to their particular use cases so that we can not only fly the drone longer distances and control it, we can get that payload data from those longer distances and be constantly uploading it to the cloud or the edge compute or wherever that data is going to be analyzed. And we can do that continuously. We also have an aviation development center that does some R&D for us. And so to prove out a particular use case, to even decide whether it's technically possible before we could turn that over, for example, to High Tech's Innovation Center to further, develop that that type of solution. Next slide. So as far as our drone management platform goes, it really does multiple things depending on how the user is. The user could be a pilot that wants to fly the drone. It could be the person administering the program, or it could be a data analyst. And so in the far left there, you see we depict the airspace as defined by the FAA for drones, and we show the airspace below 500 feet, and we simplify it so that it's not the same map that I might use as a pilot when I'm actually up in the sky flying. We simplify it, make it easy to get the information they need out of this. They can plan their flights, and then we have a mobile app that allows them to fly their flights, gather the data they need, and then that could also be uploaded to the customer's platform for analysis, or through our platform, you can create 2D and 3D models and use those tools that we also have. So we have flexibility with respect to that. Next slide. So I'd like to focus now on how drones are being used today in utilities. And this is not all the use cases, but as you can see, there's quite a few. So equipment inspections are a no-brainer, right? Anytime you want to inspect some equipment where it's off the ground, it's easier to do and set up a drone. You can do it much quicker, faster, cheaper, safer. We are using drones for transmission and distribution line assessment. There's also still today they're using manned helicopters, but they're also using drones more and more as well. If it's a gas utility with a special camera, you can actually tune to, for example, the frequency of methane. You can actually see leaks from the air, and it helps zero in on those leaks very quickly. Whether you're talking about utilities, so long linear infrastructure, whether it's pipelines or transmission lines, or even rail lines, everybody's concerned about vegetation management in assessing those rights of way as different, either vegetation takes over or even homeowners along that right of way do things to interfere there or could potentially provide a problem. You want to be able to assess that, or things like the ground shifting or different natural events occurring. Construction management and site monitoring is something that all these companies are using. Besides utilities, construction firms were our biggest vertical up until utilities, which have really taken off lately. But now we're talking about doing site surveys, surveying the grounds beforehand, and then doing progress photos as you go along. And I'll come back to one for specific to utilities in a little bit. Solar panel inspection via thermal cameras. It's actually a revolution. Previous to using drones and thermal cameras to detect a bad panel, you actually had to go out in the field, and you've seen how massive some of these arrays are. They'd have to unhook the wires and actually measure each panel individually to locate the problem. If you have a thermal camera on a drone, you can just go right above that image, and you can actually go to even a section within the panel and tell by the temperature difference which panel's bad. And so everybody that's doing anything in solar construction and maintenance are using drones today. Natural disasters are kind of a subset of the substation equipment inspection or transmission line inspection. In that case, though, they're not looking for small issues. They just want to know whether the power's there or not. And after a storm, there could be limited access to a particular area. You have flooding, you have debris across the roads. And so the ability to get a drone in there quickly that's not restricted by those types of problems is invaluable to get an assessment of exactly what the situation is on the ground. Wind turbines, hydroelectric dams, all these are just more examples of different types of inspection. Coal pile volume calculations. What's interesting is, and people don't even realize drones can do this, but we can fly over a site and map a site and create a model. That model is so detailed that you can actually go back into that model and just draw a circle around a pile of something, and we can tell you the volume in that pile. Or if there's a hole there, we can draw a circle around that and tell you what you need to fill that or what the capacity is. Also, utilities are starting to decommission coal ash ponds. And so frequently they've been storing coal ash next to these fossil fuel plants. These fossil fuel plants create these ponds that have these dams that separate that from the rivers that are usually nearby. And there was just a disaster a couple of years ago where one of those dams let go, and it created a huge environmental problem. And utilities are starting to decommission these, but for the ones that are there, a great use for drones is to monitor the condition of that on a routine basis to detect any shifts. Or for example, if you've got a hillside, let's say you're in California, you're worried about mudslides or a hillside letting go or bluff, you could fly a drone and monitor the movement of that type of geographic structure. And then lastly, at least on this list, wire transport and line pulling is huge. I'll come back to this with Southern Company in a bit, but if you remember the hurricanes that devastated the power grid in Puerto Rico a few years ago, they don't have a lot of the rights of way cleared for transmission lines. And so when they needed to restring conductors across a valley, it's nothing but basically jungle there. And so instead of hacking their way through the jungle to be able to pull those conductors, they could pull a line using a drone across that valley and then pull the conductor with that. And it takes hours instead of weeks to do that. I mean, it's pretty phenomenal when you see that. Next slide. And so, as I mentioned, Southern Company was the one to do that. I want to give a shout out to them. They've been a customer and a partner of ours for several years now. They initially came to us so that we could help them manage the drone program by providing our software management platform. But we've also done some other more advanced use cases, one of which I want to call out, and that's situational awareness. As I mentioned earlier, utilities are still using crewed helicopters to fly transmission lines. The economics are right swinging between helicopters now and transitioning to drones, and we're right in the spot where both of them are being used over the infrastructure. So the problem that creates is now you have crewed helicopters flying low over that infrastructure. In Southern Company, for example, has on the order of a couple hundred drones being used across their different operating companies over that exact same infrastructure. So that's a problem waiting to happen. And so the aviation department and Skyward has spent a lot of time thinking about how we can give the pilots better situational awareness, both the crewed aircraft pilots and that. And so we've done some experiments and tested some systems, and this is actually ongoing, where we can show the drone traffic to the helicopter pilots in real time. We can show the helicopter traffic to the drones, and the aviation manager can see where everybody is all at the same time. And with that, I'd like to turn it back over to Pete.
Hey, that's great information, Mike. You run through about 14 use cases for drones. I definitely learned something here and appreciate you taking the time and going through all of this for us. And hopefully the audience appreciated that information as well. So I was going to transition to Mauricio from Nokia. We appreciate Mauricio contributing, and I'd like to engage you to go.
Thank you very much, Pete. I hope everybody can hear me just fine. Thank you for attending this webinar. I am going to talk a little bit about how Nokia has been working with utilities in a long journey of trying to get the smart grid moving forward. And in a lot of cases, we've touched points from Bruce, from Bhupesh, as well as from Michael, on some of the use cases specifically of how things are working and where the future is going. But I think it's important to understand that utilities have gone through a process of modernization. And in the modernization process, legacy technologies still have to work with current technologies. We still have to deploy 5G networks, for example, to the use case that Mike just was talking about, drones. We've done that with a utility called NIPA, for example, testing specifically that using a private LTE network, not even a 5G at the time, with really great results. But I think that's important to see that that's where utilities are going. However, they still have to maintain their infrastructure. They still have to be able to run their operations the way they've normally done it. And with even additional requirements from a cybersecurity perspective, for example, is something we haven't talked about a little bit yet, but we've seen the impact that we're in the industry about how nation states are now attacking our infrastructure, but also from a perspective of maintaining that legacy infrastructure, because utilities tend to have equipment that doesn't change, like we normally see IT equipment changing in a period of 5 to 7 years, for example. Utilities maintain a technology for about 15, 20, even more years, because that's really how things work in that industry, in the mission critical type of operation. So if you go to the next slide, one of the things that we've been doing is working with Bell Labs. Bell Labs is part of the Nokia family of companies, and they've done a lot of research, and they keep moving research. And one of the things that they've done is actually define an architecture for the next 10 years. That's what we call Future X. And Future X, the X stands for the next 10 years, really looks at how utilities are going to work from different levels, from the pure connectivity layer, which is shown at the very bottom, which is high performance networking, where we are seeing now all kinds of new methods of connecting things, not only from a 4G to 5G perspective. We're seeing increases in the actual bandwidth that we're doing with fiber, for example, where we now see very commonly 400 gigabits per second on a single connector for fiber, right? And that is normally. Now we're seeing, like, for example, tests that we've done with Bell Labs of 400 terabits per second. So it's interesting the magnitude of the actual technology that we're seeing, but that just alone won't cut it. We also have to look at what else we provide there from a multi-cloud. And that's something that Bhupesh was talking about, is where is the actual intelligence now in the network, whereas it used to be monolithically in the data center. Now it actually can be found at the edge. And at the edge is very important because we can actually meet now the requirement of mission critical applications that are really low, have requirements of low latency, ultra reliable low latency, as 5G NOMER assesses. So now the distribution of all the intelligence within the network in a multi-cloud environment is important. We also have the value platform, the digital value platform that adds on artificial intelligence, for example, machine learning, that create potential venues for automation. And that's really where Industry 4.0 is going. But all of that basically is built on that. All of that AI and ML that comes into optimizing, automating, and basically taking away the capacity of human error to be introduced within the actual running of these mission critical networks is there now. And that actually is completely finished, I would say, within the actual workforce efficiency and safety, which is a paramount for electric utilities. Electric utilities really want to keep their people safe, to the point of not having flying helicopters and bringing drones in order to avoid the liability, for example, in that use case, but also because we're trying to do optimization, automation, all the assets that we have. All of that has to be all wrapped around cybersecurity in a closed loop, because that really creates that environment where it's safe, where you can bring in new applications that can interact with the older applications, maintaining the obsolete or the ones that are obsolete, or at least at the point of being obsolete, but not being able to change it with the very newer ones. That is the actual idea of the Future X architecture, which Nokia has been deploying with utilities at a certain level, depending on where they are in this process of going to the smart or the smarter grid. So if we go to the next slide, please. We will see that we actually have been working in many different fronts. We've been going from critical network transformation, and that's something that Nokia has been doing for many years now, where we have IP MPLS, we have DWDM, we have microwave products, as well as the software that makes it all run. And this goes from the traditional backbone type of modernization and the way that we are now converging all the use cases, all the applications that were done before as separate networks into one single infrastructure that could be managed, that could be leveraging the exact same hardware, and it can actually be easier to maintain from a resource perspective. Now, remember how many engineers we had to do with one single SONET network, when other ones were still working on traditional technologies like T1s. So it was very difficult to do that at one point in time. And I say we used to, because I used to be part of a utility. I worked 10 years at a utility seeing these kind of problems. Once we skip that part, or when we pass the part of actually now having the backbone that is properly configured, we have the newer technologies. We have a private LTE, private 5G. We still have IP MPLS, which is extending into those realms. extending the service capability of providing a one-click service configuration, for example, which is really needed for a lot of the utilities. We have GPON, and we still rely on software. Why software? Because as we move along, one of the key things that we've seen is that software is what defines where the progress is going to be. The technologies will be there, the connectivity will be continually evolving, but the software and the way that it's run, and actually going to the Bhupesh's presentation, that's really where the value now for all the utilities and all the companies is. Where do you offer the software and what applications are there? That's where that differentiates the enterprises from the carriers, where carriers really focus on connectivity. The utilities really focus on mission critical software. So that's where we are. And we also continue moving to different types of empowering new business models and connected generation and virtual power plants, because that's where the future of the utilities is. We don't see utilities now being the top-down generator, producer, and distributor of all the product that we did. Now we're seeing distributed energy resources that actually are generating by individuals, and that capacity has to be, by legislation, now fed back into the grid. So having said that, the utilities are not the producers anymore or the distributors anymore, they are the brokers, where now they have some capacity coming from one side, some additional capacity coming from the other side, and they have to be able to monitor the technology, monitor the grid in order to avoid problems, because this is not like traffic. This is really something that can make things blow up, right? If you don't properly control the flow of the electricity. And they have to be able to account for all of that, because now they have to either give credit back to the one who was producing or charge more to the one who was consuming extra. So that is the new model, and that's where Nokia has been supporting, not only from a technology perspective, from the traditional convergence of the IP of the single-use type of networks into an IP and PLS converged network with quality of service, obviously, and moving forward to the newer technologies. And if we go to the next slide, please. I think I'm talking a little too much here. I get excited. One of the things that we're seeing is how now.
Mauricio, you're doing great, and we have 9 minutes left, so you're good. You're good.
Perfect.
Yeah.
Great. So with generation and going as being one of the first things that obviously utilities have to look at, the ones that do generation, and trying to maintain that environment properly connected and secured, moving all the way to the field air network, we've seen a drastic move from single type technologies into a converged network. And that's really the key, as I mentioned before, of having all of the networks relying on one single underlying technology, all the applications, all the use cases, because that's where the key is. As we see newer requirements from distribution automation, for PMUs, for drones, for example, you see that each of these use cases have specific requirements and needs, either from a bandwidth perspective, where we're seeing, like Bruce mentioned, multi-gigabit or requirements for data that are going out to some of the users, and going back to the drones, where you really require a network that is 100% reliable, and they can bring in the control, the command and control information, because now you have a vehicle that's flying and potentially it's sharing the airspace with helicopters. Now you have to be able to maintain the quality of that network to, let's say, 6 or 7 nines, right? So it's very important to have connectivity, and going all the way back to supporting what we used to have in the utility known as SCADA, which was 9.6 kilobits per second. I remember one time we were deploying a fiber network to support 9.6 kilobits per second circuits. I mean, that's incredible to hear now, right? So, but that's how utilities used to work. So it's important to understand that converging all of that traffic into a single infrastructure is the key. Defining the parameters of all of the use cases from a bandwidth perspective, from a latency perspective, from a survivability perspective, it's very important. And quality of service that extends not only on the backbone network, that extends all the way to the field air network is very important. So different types of products and different types of portfolios and different types of connectivity options have been provided by Nokia, ever since we were Alcatel-Lucent, and even before that, because, obviously industry, as these companies evolve, they start gobbling up smaller companies. We had that portfolio evolve into what we have right now. So the next slide shows a little bit of the types of connectivity options that we have. And in some of those, you will see that in order to support generation, go to the transmission grid and finalize in the distribution grid, now we have a plethora of options going from your typical DWDM, series of products that we actually offer to support up to 400 gigabits per second now in a single fiber that you can split up and use at the leisure of the utility based on what they need. And also creating new business models for potentially middle mile type applications, which nowadays are very important as we have to deploy more and more infrastructure, not only from a private perspective, but from a commercial perspective. Commercial carriers now are looking back to utilities saying, you guys have fiber everywhere. Can we use it? Now, there are many obstacles for that to happen. Some of them are regulatory. Some of them are, how does utilities will actually change their business model to accommodate some of this. Some of them have done that, by the way, not only here, but in other parts in the world. But it's important to understand that now fiber is a really huge asset, and maximizing that using DWDM, for example, really makes sense for utilities. Having that as well as a backup link, right? We talked about some of the links that Bruce and Cambium are doing 60 gigahertz. We have a plethora of other options of other bands that not only support the gigabit speeds, but they also support the actual current applications and are the fallback for the fiber. Because fiber, you've always heard it, it always, for some reason or not, gets in the way of backhoes, or there are some groundhogs that go chew it, like we have to do in Oklahoma here. We actually had, those little critters chewing on the fiber, and other, events that may happen, like weather events, that actually make it such that you have to have a backup of that link. So that's where microwave and wireless communications still play a fundamental role. And now we're seeing that, for example, like in the case of the pandemic, we see that companies, carriers, commercial carriers, don't have service everywhere. There are areas that are underserved. And that actually was a pain point for education when the kids couldn't get to school in virtual environments during the pandemic. So now technologies like GPON that are being deployed on top of the utilities fiber are now becoming very important to support this type of engagements. And even GPON as a way to carry private wireless to the very last hop into the house of those underserved areas, for example. So those are all the technologies that we see now playing all together from a connectivity perspective that then give way to the applications, the myriad type of use cases that we see, not only from a utility perspective, but I'm talking about education now, moving forward in the market. So we see, and we have the portfolio in Nokia to support all of that. We have a track record of supporting utilities in, for many years, and we actually, like I mentioned, you guys, Nokia Bell Labs is there behind doing a lot of the research on the newer technologies. So this is just a quick glimpse of what we've done and what we have in industry supporting utilities. And in the last slide is just a little bit of some of the use cases that we have tested, and you will see that on the very top row of it, where not only we're providing connectivity from a voice perspective, which is traditionally on the communications on the carrier side, whether it's just traditional voice or VoLTE or voice over NR or 5G. We also have been looking for video surveillance as well as to support SCADA. We also are supporting access to cybersecurity assets by supporting, different types of methodologies of encrypting and providing access to secure locations, as well as ensuring that the traffic is properly handled. We're looking at newer applications like drones or augmented reality, or the mixed reality, which is called now, in which you are combining not only this new technology of having things show up in the HoloLens, for example, on the Google glasses, but also you are connecting and creating the remote expert, which can see through your eyes and it can show you in front of you what you need to do. So that type of applications is driven by communications, obviously, as well as automation. And that's really important to understand that as we move forward, we see that automation, the Industrial Revolution 4.0, is becoming a commonplace now. And without having solid networks, without having an end-to-end portfolio of applications and connectivity that actually ensures that those networks are available, that's not necessarily going to go anywhere. So that's really what I had for you guys today. Appreciate it. And hope to hear some questions if you have some.
Yeah. Oh, hey, Mauricio, great job, great contribution. Appreciate you highlighting security. We focused initially on connectivity, applications, edge computing, but obviously security is paramount in the utility segment. Unfortunately, we covered so much ground that we ran out of time. But we're sharing on the screen here the contact information from Future Tech. So, and this will be available, but what we would hope to do is we're happy to receive email questions, we'll respond those back. We're also happy to set up workshops with the attendees to maybe do some use case demos, get into the connectivity. We can work back with Mike. Maybe we could do a drone flight test, demonstrate the capabilities of the software to best manage that mixed use of helicopters and drones, and talk about how the software can help that from a safety perspective. But definitely appreciate everybody's contribution today, and hope everybody has a great week. And we'll look for questions and hopefully follow up. But thank you for the time today.
Yeah, thank you all for joining us today. There was a quick question in the chat here that just asked if we could send the slides. For those who joined us a little later, this presentation has been recorded and will be available for all registrants. I will be posted in UTC Networks, and you will receive an email once the presentation has been posted in that community in UTC Networks. So thank you once again to all of our presenters today. Thank you to Future Technology for sponsoring today's webinar, and we hope to see you all in a future webinar here at UTC.